In this demo, we would like to review the operation of the S121 Human Readable Text Validator. The objective of this tool is to do some quality checks on the human readable text output in comparison with the source S121 GML from which it was derived, just to check how that HR text generation, how well it worked. And in theory, it could be used to compare any S121 GML with its associated HR text. So the main process steps are reading the S121 GML dataset, then reading the S121 HR text. And then there's a number of steps with the HR text to extract features. First, we have to parse the feature types, map them to the appropriate or extract the ones we're interested in this case, location feature type, extract location data from the text, including, let's say, from degrees, minutes, seconds, and converting that to decimal points. Then generating the point geometry and setting the coordinate reference system. And finally, we compare the HR text features that have been derived from the text with the S121 GML, both based on location and on ID and name, feature names. And we look for differences between the two, HR text not in the GML, GML not in the HR text, and matches. And then for each of these result sets, we built a series of tables and maps so that those results can be more readily viewed. Here's a quick look at the human readable text input that we're going to assess against the GML. And you can see that it's a very well structured data set with blocks of data for each feature type. Here's a metadata block, governance, basic administrative unit, and here, this block here is the location data that we're going to extract into location features. Here's a quick look at the FME data transformation workspace that was used to compare the HR text with the S121 GML. And just to quickly walk through how this works, a big part of this workspace is really the processing of the text so we can extract it into feature attributes and geometry. So the preparation of the feature data so that we can then compare it with what we read from the GML. So first step here on the bottom left, we read the S121 GML. And then up here on the top left is where we read in the text data, human readable text. And a key part of this, the next step after that is the feature type mapping. So here's where we basically pick out the location data, and we're also using the limits as well because there's information from that we need. And you can see there's a number of parsing. We do a lot of list processing and splitting by either keywords, or in this case we're using some of the punctuation on the degrees, minutes, and seconds to pull apart different coordinate values. In this case, degrees, minutes, and seconds, which ultimately have to be converted into decimal degrees. And then after that, we convert it to an actual vertex and generate point geometry and set a coordinate reference system. So there's a number of steps there. You can look at in detail if you want to download the workspace and go through it. Ultimately, once we've extracted the point geometry and some of the key attribute values, then we have actual features that we can compare. So the core of the processing in this workspace really is the change detector, where we use the location and the ID to do our matching, and then we look at differences both in terms of position, ID, and feature name. And then based on the type of the results of that comparison, we group our results into these 4 different groups. The first group are where there are some kind of difference between either based on location or ID that doesn't quite match. Or we have locations that are clearly not in the GML from like HR text locations, or we have GML points that are not in the HR text. And then finally, we have the points that are coincident, that match in both. And then for all these results, we sort them and then build an HTML report with both a map and table for those results. So we can go ahead and run this, and we'll get some output both in the FME data inspector as well as some feature data. And we can see here's the input HR text points that we've read. This is the GML, and clearly here are the points that are in the GML but not in the HR text. Points in HR text that are not in the GML. These are the ones that actually match, so they're in both, and these are the ones that where there's some differences between the two. And it's a lot easier to inspect that. We'll come back to some of these in a minute. Yeah. So we'll just look at the results now in terms of the HTML report. And we can see here are the locations that actually match. So these line up. They line up from both the human readable text and the S121 GML. Here are some points. Obviously, because the HR text is only for area 2, which is close to Newfoundland, we wouldn't expect these points to be in the HR text, but it's a good check to make sure this tool is working. And then here are a couple of points that are in the text but not in the GML, and that could be because of a difference in location. A slight offset might be because the DMS degrees, minutes, and seconds, so those points are different enough from the decimal degrees that they might produce a mismatch. And then here are where there is a difference, either the location or the ID or both. And so here's we just have a location 28 highlighted, and the reason why that's interesting is that we can see here location 28 is Blackhead North, and if we pop over here we can see that we zoom in a bit for that location. We have Blackhead North, location 28 in the HR text, but if we look at the GML for that same location, we can see that they actually have a suffix, so it's like Blackhead North 1 or 2. So that's probably why we're getting a mismatch there. There's a slight difference in the name that didn't make it into the HR text. So just to wrap up, the human readable text validator, it's kind of a first cut at analyzing the HR text output, comparing it with the S121 GML baseline from which it was generated, and looking for matches and differences. And the whole idea is to automate as much as possible, some quality checks, and in the future it would be useful to add other feature types to compare. Thank you.